Hey class, today's lesson is on ions. An ion is an element that has gained or lost electrons. Remember, we've spent a lot of time talking about how the elements on the periodic table, as they are, have the exact same number of protons and electrons, meaning they are neutral. But what happens when that element either gains or loses an electron or more than one electron? Well, it's no longer neutral and becomes an ion, which means it has a charge. If you think back to the arrangement of the periodic table, you'll recall that we talked about noble gases. Noble gases are the last column on your periodic table, group 18. So it's helium, neon, argon, krypton, xenon, radon. Okay. What's special about noble gases and what makes them really popular is the fact that they are completely stable. And what does that mean? It means that, what makes them good is that they are stable. Stable means that their last shell is completely full. They have no room to either gain or lose electrons. So noble gases have outer orbits that are completely full. How do other elements become stable? Well, in order to have a full outer shell, either you're going to have to gain or lose electrons. So an ion is an atom with a charge, and it's formed when an atom gains or loses at least one electron. If we go back to our example of lithium, right? Lithium had 3 protons, 4 neutrons, okay, and then 1, 2, this is a terrible drawing, 3. You know what, let me draw this again. Make this better for you. Okay, 3 protons, 4 neutrons, and then it has 4 electrons, so it would have, 3 electrons, so it would have 2 electrons in the first shell and 1 electron in the last shell. This is lithium. Remember, our electron arrangement says 2, 8, 8, 8, right? So 2 electrons max can go in the first shell, and then all the other shells can have a maximum of 8 electrons. Well, our first shell is complete, so I'm going to give it a check mark. Our second shell only has 1 electron on it. That means I have an empty space here. I have 2 more empty spaces here, here, and here. I actually have 7 empty spaces. So lithium definitely could lose this 1 electron, or it can gain 7 electrons. So there is some room. Lithium is definitely not a stable element. So how many protons and electrons does lithium have? Well, it has 3 protons. It has, therefore, 3 electrons. If I was to draw my Bohr-Rutherford diagram for lithium again, here it is. Okay, so you have your 2 electrons in your first shell, and you have your 1 electron on your last shell. Let's look at that Bohr-Rutherford diagram. How many valence electrons does lithium have? When we say valence electrons, we're talking about how many electrons are there on the last shell. Valence electrons are the electrons on last shell. If you go back, you'll notice that there was 1 electron on the last shell. So what does lithium have to do to become stable then? How is it going to have that outer shell become full? It's either going to lose 1 electron or it's going to gain 7 electron. And then you have to ask yourself, which one is easier? And the easiest option is always the smallest number. So losing 1 electron is way easier than gaining 7 electrons because it takes a lot less energy. So remember, to start with, lithium had 3 protons, it had 3 electrons, and it had 4 neutrons. But if lithium loses electrons, it's no longer neutral. Now it's an ion. So now, instead of having 3 electrons, if it loses 1, how many electrons is it going to have? Well, the protons are going to stay the same. But now the electrons are only going to be 2. So if there's 3 protons that have a positive charge and 2 electrons that have a negative charge, what's the overall ionic charge of lithium now? It's going to be 1 plus. 3 subtract 2 is 1. What charge is there more of? Well, there's more positive than there is negative. So lithium has a 1 plus charge. The chemical symbol for an ion contains the element symbol and its charge. It's really important. When we're talking about ions, you have to include the ionic charge or it will be incorrect. So lithium is 1 plus. Okay, so you have the symbol and you also have the charge. Okay, try the next one on your own. How many protons and electrons does fluorine have? I hope you've written 9 protons, 9 electrons, and 10 neutrons. If you had to draw a Bohr-Rutherford diagram for fluorine, it should be 9p, 10n. Your Bohr-Rutherford diagrams are going to be way nicer than mine. Okay, there's my 9 electrons. Looking at the Bohr-Rutherford diagram, how many valence electrons does fluorine have? Well, there's 7 electrons on the last shell. Okay, that means there's 7 valence electrons. How many electrons can fit completely on that shell? Remember, there's 8 electrons that can fit, so keep that in mind. So what does fluorine have to do to become stable, to have that full outer shell? Well, it's either going to lose the 7 electrons that it has, or it can gain 1 electron to have a full 8 electrons on that last shell. So which one is going to be easier? I hope you answered gaining 1 electron because it's the smaller of the two numbers. It requires a lot less energy. So if fluorine gains electrons, it's no longer neutral and now it's an ion. So let's do a final count of protons and electrons on our sheet. So the protons never changes, it stays the same. So fluorine has 9 protons. But now that it gained 1 electron, it's going to have 10 electrons. What's 10 subtract 9? 1. And what is there more of? Is there more proton or electron? Well, now there's more electron, and electrons have a negative symbol, so the charge on fluorine is going to be 1. Okay. And remember, the chemical symbol for an ion contains the element symbol and its charge, which means fluorine is going to have a -1 charge. You don't have to write the 1, so the negative symbol reflects it. There is a quick way to figure out the number of valence electrons if you are looking at your periodic table. The column number actually will tell you the ionic charge of the elements, but this only works for the main 8 groups on the periodic table. So group 1, your alkaline metals, your alkaline earth metals, right? Then 3, 4, 5, 6, 7, and 8. So be careful. So it has a 1 plus charge, a 2 plus charge, a 3 plus charge, and then be careful with 4, 5, 6, 7, and 8 because those numbers don't indicate the actual charge. It just tells you the number of valence electrons in each group, which means if there's only 1 valence electron in this group 1, then you're going to lose that 1 electron, so you're going to have a 1 plus charge. Here, you're going to lose these 2 electrons because there's only 2 electrons in your last shell, so you're going to have a 2 plus charge. And here, you're going to have a 3 plus charge if there's only 3 electrons in your valence shell. But in our 4th group here, for example, carbon, if there's 4 electrons in your last shell, what's going to happen? Well, you're going to have a 4 minus. And then here, if there's 5 electrons in your last shell, well, you're going to gain 3 electrons, so you're going to have a 3 minus. charge. And here, if there's 6 electrons in your last shell, well, you only have to gain 2 electrons, so it's going to be a 2 minus. And a 1 minus here, because if there's 7 electrons in your last shell, well, you only have to gain 1. And remember, these are full. They're stable. So there's no charge, okay? So it goes 1 plus 2 plus 3 plus, then 4 minus 3 minus 2 minus 1 minus, okay? Here we're looking at magnesium and nitrogen. If you pause the video and try this on your own, you should be able to get these answers as well. Valence electrons, so your electrons on your last shell would be 2 for magnesium. That means magnesium is going to lose those 2 electrons because it's a lot easier to lose 2 electrons than to gain 6. So the charge is going to be 2 plus, and the ion symbol would be Mg2 plus. Okay, so try these out on your own and make sure you get those same answers. There are 2 different types of ions. A cation is a positively charged ion, so when the charge is positive. Your metals are always cations. An anion is a negatively charged ion, so it has a negative charge. And these are your nonmetals. A good and easy way to remember the difference: anion sounds like onion. Onions make you cry. That could be negative. Okay. Now, drawing ion Bohr-Rutherford diagram. So you are going to be responsible for also drawing the ion Bohr-Rutherford diagram. So in the next few slides, I've done it for beryllium and oxygen for you. 2 things to note for ion Bohr-Rutherford diagrams: you have to show the new number of electrons that have either been lost or gained. So your number of electrons is going to be depicted. And you also need to include the element symbol with its charge. So, for example, here's oxygen. The regular oxygen Bohr-Rutherford diagram, the way you know how to do it, is here. Okay, so this is how... This is how we regularly draw them, right? The normal oxygen Bohr-Rutherford diagram. 8 protons, 8 electrons, 8 neutrons, 2 electrons in your first shell, 1, 2, 3, 4, 5, 6 electrons in your second shell. You have 2 empty spaces, right? So is oxygen either going to gain 2 electrons, or is it going to lose the 6 that it has on that last shell? Well, I hope you answered that it was going to gain 2 electrons. So it now is going to contain 10 electrons. When you draw the ion for the oxygen Bohr-Rutherford diagram, you have to show those extra 2 electrons. So when I count all the electrons, I should see 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Please note that the number of protons and neutrons never changes. So now I've shown the new number of electrons. I have my element symbol, including its charge. That is this right here is how you draw the ion Bohr-Rutherford diagram. It includes the Bohr-Rutherford diagram with the added, so the gained or lost electrons, and it has the element symbol with its charge. Okay, here's beryllium. So beryllium has 4 protons, 4 electrons, and 5 neutrons. On the left-hand side, this is the regular Bohr-Rutherford diagram, so you would have 4 electrons represented. Now, is beryllium going to gain all of these electrons? So it has 6 empty spaces, or is it going to lose these 2 electrons? I hope you answered that it was going to lose 2 electrons. So when it loses 2 electrons, instead of having 4 electrons, it's now going to have only 2 electrons, giving it an overall 2 plus charge. So when I draw the ion for the Bohr-Rutherford diagram, the first shell has 2 electrons, and that's all that is needed because it has lost the other 2 electrons. I have my element symbol with my charge. Okay, that brings us to the end of this lesson. Email me if you have any questions.